Let's jump right into the world of open source intelligence, or OSINT. But listen, we aren't just talking about doing a few simple web searches here. In this explainer, we're going to break down how to design, build, and actually automate a professional OSINT toolkit. Whether you're tracking down a digital footprint, analyzing a complex network, or gathering threat intelligence, the sheer volume of data out there means you absolutely need modern software development techniques. We'll be diving into how to use Python, APIs, and artificial intelligence to automate the entire intelligence lifecycle, literally from collection all the way to reporting.
So here's the fundamental problem every investigator faces today. How do you find a needle in a digital haystack when that haystack is, well, the size of the entire internet? The scale of our digital footprints is just overwhelming. Every single day, massive amounts of data are generated. Social media posts, server logs, domain registrations, leaked databases, you name it. If you're relying on manual collection, clicking through pages one by one, you're going to fall way behind. Manual collection just doesn't cut it anymore. We need systems that can collect, normalize, and analyze data at machine speed, but without losing that crucial human critical thinking required to actually make sense of it all.
Here's how we're going to break this down today. First, structuring the investigation. Second, automating with Python and APIs. Third, AI-assisted analysis. Fourth, visualizing data. And finally, ethics and best practices.
Okay, starting with Section 1, structuring the investigation. Because honestly, before we write a single line of code, we really need a solid plan. Just think about the sheer scope of what an investigation can entail. Take a look at the MIT REC attack matrix, specifically focusing on the reconnaissance stage. Notice the massive range of categories here. Everything from active scanning to gathering network infrastructure data and searching open sources. An investigator really has to consider all these potential vectors to find things like corporate email addresses, open ports, or hidden website directories. Without a structured workflow to handle all these possibilities, you literally just drowned in a sea of unrelated data.
To avoid that kind of chaos, we turn to 3 foundational questions from the Open Source Investigation Handbook. Every analyst absolutely must answer these before touching a single tool. Number 1, what prompted the investigation in the first place? Number 2, what are the key questions that actually need to be answered? And 3, which tools and platforms can help gather that specific info? By defining your objectives and scope up front, you ensure your automated tools are hyper-focused. This stops you from just aimlessly scraping the web, which, trust me, saves you from burnout and hours of wasted time. Moving on to Section 2. Automating with Python and APIs. This is where we make that jump from manual clicking to some seriously powerful automated data gathering.
Now, before we automate anything, we have to understand the data we're actually dealing with. Data generally comes in 2 distinct flavors. On one side, we have structured data. This is highly organized information in a predictable format. Think of a pristine spreadsheet, a database table, or specific HTML tags. It's incredibly easy for a script to extract. On the flip side, we have unstructured data. This is your messy, raw text, images, videos, and social media posts. Because it lacks a predefined format, it's much harder to scrape and analyze. A truly robust OSINT toolkit has to be built to handle both the organized and the messy.
When it comes to extracting this data, efficiency is the hallmark of a skilled OSINT practitioner. Web scraping scripts act as the engine for automated collection, letting you pull down massive data sets effortlessly. And Python? Python is definitely the go-to programming language here. We use specific libraries, kind of like pre-built toolboxes, such as Beautiful Soup and Scrapey. They make it surprisingly easy to write scripts that go out to target websites, navigate their structure, and pull exactly the data you need, completely eliminating manual data entry and human error.
But let's be real, scraping the front end of a website can sometimes be pretty messy. So a massive advantage comes from leveraging APIs, or application programming interfaces. Instead of having a Python script pretend to be a human reading a web page, an API lets your script talk directly to a platform's database. Think of it like a dedicated service window at a restaurant. You hand them a structured request, and they immediately hand you back your structured data in real time. Whether you're querying social media platforms, domain registration databases, or geolocation services, integrating APIs is, hands down, the most reliable way to build a lightning-fast intelligence pipeline.
Now, if you don't want to build every single integration from scratch, professional automation frameworks have totally got your back. Tools like Spiderfoot, Maltego, ReconNG, and Foca act as these powerful command centers that provide pre-built modules for data gathering. Spiderfoot, for instance, can collect information from over 200 data sources simultaneously to build a profile on an IP address or domain. These act as incredible time-saving shortcuts. They take the data received by one module and automatically use it to query the next, enriching your intelligence layer by layer on absolute autopilot.
All right, Section 3, AI-assisted intelligence analysis. This is the ultimate force multiplier, because once you've automated collection, you'll often have way more data than a human could read in a lifetime. One of the most fascinating applications here is LingIntent, linguistic intelligence. AI tools can analyze intercepted communications, dark web posts, or encrypted chats to identify hidden linguistic patterns. They can detect specific slang, jargon, or communication habits that actually help track criminal networks. It's not just about what is being said, but exactly how it's being said. This reveals underlying relationships and intent that standard keyword searches would completely miss. Beyond just language, AI provides massive advantages across the board. Computer vision algorithms can analyze images and videos to detect manipulations, like deepfakes, or to verify physical locations. Then you have entity recognition. These algorithms automatically scan massive text dumps to pick out and link names, organizations, and locations, instantly mapping out relationship networks for you. And broader machine learning algorithms, they are incredible at pattern recognition, sifting through server logs or network traffic to spot anomalies that might indicate an emerging cyber threat. Which brings us to advanced large language models. Platforms you probably know well, like ChatGPT, DeepSeek, or Gemini, alongside underlying models, like BERT, are totally revolutionizing workflows. They can summarize massive documents and translate foreign text instantly, saving you literally hours of reading. Meanwhile, specialized tools like Sensity AI and Sentinel are trained specifically to detect disinformation in real time. Rather than replacing the investigator, these AI models act as highly capable assistants that process all the heavy lifting for you.
Section 4, Visualizing and Reporting Data. This is all about presenting your findings, because raw data is completely useless if you can't communicate it effectively to decision makers.
To make sense of really complex relationships and timelines, we use visualization tools. Applications like Draw.io and Gephi are excellent for building out intricate link charts, showing exactly how different people, companies, and digital assets are connected. For chronological data, tools like StoryMap and Event Viewpoint help you plot out events on a timeline and a geographical map. Visualizing data isn't just about making it look pretty, right? It's a critical analytical step that often reveals hidden connections you would never ever spot just staring at a spreadsheet.
After visualizing the data, you must deliver a professional report. A standardized summary profile presents the intelligence clearly and concisely. It outlines the subject's identifiers, addresses, and social networks right up front, followed by a clear summary of findings. Delivering your results in a clean, standardized format is a critical step that is so often overlooked by new practitioners, but it's exactly what separates amateur scraping from professional intelligence gathering.
Alongside the summary, you absolutely need a detailed case narrative. This means explicitly documenting exactly how you configured a fresh virtual machine, the specific search engines you used, and the exact URLs and extensions utilized to preserve the data. This level of documentation is vital. It ensures your investigation is entirely reproducible, that the evidence is archived properly, and that your workflow can actually withstand rigorous legal scrutiny.
Finally, Section 5. Ethics and best practices. This is all about responsible OSINT, because building powerful tools means you carry a pretty heavy responsibility.
When operating an automated OSINT toolkit, you must adhere strictly to legal and ethical frameworks. First and foremost, you've got to comply with global data privacy laws like the GDPR and the CCPA when dealing with personal information. When you're using APIs, always respect the provider's rate limits and terms of service, and for sure keep your API keys securely locked down to prevent unauthorized access. Lastly, maintain robust data validation. Always verify uncertain data across multiple sources before ever treating it as a fact.
I really want to highlight this specific quote from our source material. Humans need to view the output of automated tools to know whether the collected data is reliable and trustworthy. Automation and AI are fantastic for scale and speed for sure, but they can hallucinate, and algorithms can definitely have bias. You simply cannot blindly trust the output, and investigators' critical thinking and oversight are always required to validate the evidence.
To quickly summarize the entire automated lifecycle we've covered, you start by defining your scope. You collect and automate those repetitive tasks using Python and APIs. You pass that structured data into AI models to extract hidden patterns. You visualize those findings using link charts and timelines. And finally, you generate secure, reproducible reports. It's a complete pipeline.
We are entering an era where generative AI and automated scraping can uncover almost anything that leaves a digital footprint. As AI continues to evolve and becomes even more capable of finding that needle in the digital haystack, how will we ensure that our digital investigations remain both flawlessly efficient and uncompromisingly ethical? It's a delicate balance of immense technological power and human critical thinking, a balance every single modern investigator must master. Thanks for joining me for this explainer. Keep learning and always investigate responsibly.